Hey guys, it's Sonia. Today we're going to be learning about the force of drag on airplanes. So let's get started. Drag is the force that acts opposite to the direction of motion. It is caused by friction and differences in air pressure. It slows down objects. An example of drag is putting your hand out of a moving car window and feeling it pull back. These are the four forces that act on airplanes. The lift force is going up. The weight of the plane is going down. The thrust is the direction in which the plane is moving, and the drag will be in the opposite direction. I saw these forces in action at a recent air show in Houston. The book explains that the resultant force in the direction of the upstream velocity is termed the drag, and the resultant force normal to the upstream velocity is termed the lift. I decided to test out these forces with two separate paper airplanes to see how they will fly. The first paper airplane was a simple plane with a pointed nose, which did not fly very well. The second paper airplane was a more complex design with a snubbed nose and did better flying. From these examples, we can see all four forces acting on the planes. Me pushing the plane is causing the thrust force. Meanwhile, the force going against the plane will be the drag. The air underneath the wings will be the lift force, and then the weight of the plane mixed with gravity will be the weight force going down. While researching this topic, I wondered if drag would increase or decrease with an increasing or decreasing altitude. I discovered that at higher altitude, we'd trade the lower air density for a higher true airspeed, but not for a lower drag. What would be the impact of drag on small versus large airplanes? A smaller cross-section will cause less drag than a larger cross-section. The wider an aircraft is, the more drag will be caused, and the width will always be the most important factor of drag. In this 3D example, we see all four forces acting on the airplane. We see how thrust pushing the airplane will cause it to go forward and slightly up. We see how the force of drag can push an airplane back. We can see the force of lift as it will get underneath the wings and cause the plane to rise. And then we will see the force of weight as the plane is lowered a little bit with the force of mass and gravity combining. All of these forces acting on the plane are very important and all make an impact on how the plane will fly and the power that will go into it as it flies throughout the air. If you wish to calculate the drag and lift forces, you will need to know the pressure and the shear stress on the body to calculate these equations. To carry out the integrations and determine the lift and drag, we must know the body shape and the distribution of the shear stress and the pressure along the surface. These distributions are often extremely difficult to obtain, either experimentally or theoretically. The pressure distribution can be obtained experimentally by use of a series of static pressure taps along the body surface. However, if you wish to calculate the drag coefficient, all you will need is the drag force divided by 1/2 density times the velocity squared times the area. In this video, I hope that you learned more about the forces that act on the airplanes and specifically the drag force that pushes against these planes to slow them down.